Okay, so I'll just go over a few questions with you here. Just some of the first ones here. I'll do 1A with you, first one on your assignment. Use the LCD, now that's the lowest common denominator, to eliminate the fractions from each equation. Do not solve. So they're basically asking you, can you look at these denominators and spot what the lowest common denominator would be, or the lowest common multiple, I guess, really, is what we're looking for of all these numbers. So you wouldn't want to multiply by 3. Okay? Why? Because it's not going to eliminate the 4. And it's not going to eliminate the 12. You'll still have numbers in the denominator. So you want to multiply by the biggest number that is a multiple of everything. So that's 12 here, isn't it? 12 is a multiple of all of these. And so if we did multiply that, we would have 12 divided by 3 is 4 times x minus 1 for the first term. 12 divided by 4 is 3. So we'd have 3 times this next numerator here. And 12 divided by 12 is just 1, so that equals 5. And 12 divided by 6 is 2, so we'd end up with a 2x there. So that's how you would eliminate the denominators. It says don't solve, just go ahead and eliminate the denominators. Okay? If you still don't understand that, for the second, or let's go to C here. This x squared minus 9 we know is x plus 3 times x minus 3 when it's factored. And so I would multiply everything here by x plus 3 times x minus 3 to get rid of those factors. And that would leave me with, over on the far left, just a 4x, because all of the factors would divide out. These two factors times this middle term, well, the x plus 3's would divide out. And I'd be left with 5 times x minus 3. And then these 2 times 2 would simply be equals 2 times x plus 3 times x minus 3. And that would be your answer there. Eliminate the denominators. Questions about number 1? Okay, number 2, solve and check each equation. Here we go. Identify all non-permissible values. Okay, non-permissible values, there are none in the A. Why do I know that? Because there's no variable in the denominators. If there's no variable in the denominators, then there's no restrictions or non-permissible values for F. So I'm going to multiply everything here by 6, because that's the lowest common multiple of 2 and 3. So again, if you need to see this a little differently, I'll write this separately. How about that? So every single term gets multiplied by 6. Okay? Which means this, 6 over 2 is 3. So I'm left with 3 times f plus 3. Okay? Minus 6 over 3 is 2. So I'm left with 2 times f minus 2. And then finally over here on the other side of the equal sign, I've got 6 times 2 is just plain old 12. So I carry this further by expanding and gathering all like terms, isolating for my variable if I can. So this is 3f when I distribute there plus 9. Now this, be careful with your negative sign, right? It's negative 2f plus 4. Okay, it's a negative 2 times f and a negative 2 times negative 2. So please be careful with that one. And then we just have a 12 over there. So I get f. 9 and 4 is 13, so f plus 13 equals 12. F equals negative 1, it appears. Okay. To check that, I would just put in negative 1 in for f. So negative 1 plus 3 over 2 minus negative 1 minus 2 over 3 equals 2. Negative 1 plus 3 is negative 2 over 2 minus a negative 3 over 3 equals 2. Negative 1 plus 3. Oh, sorry, that's a plus 2 there. Negative 1 plus 3. So I have 1 plus 1 equals 2. Checks. So number 8 is the next one here that we'll do. The sum of two numbers is 25. And so this is kind of a word problem that you want to set up, again, as an equation with an unknown in there. So the sum of two numbers is 25. The sum of their reciprocals is 1/4. Determine the two numbers. Okay. So if we're going to solve, we're going to want to use just one variable if we can. Okay? That's the key, one variable. So how can I represent the two numbers with one variable? Well, if one number was n, let's say, then we're going to have the next number, and we've done something like this before. It's the difference between 25 and n, right? So you have n here, and this is 25, right? So if they both have to add up to 25, this is 25 minus n. So that's the first step. The second step is to write an equation or put together the rest of the information in the question. So the sum of their reciprocals. Now reciprocals, the reciprocal of n is 1 over n. The reciprocal of 25 over n is 1 over 25 minus n. Sorry, 25 minus n. So those are the reciprocals. The sum is adding. And they equal, or that is, the sum is, that equals 1 over 4. So here's the equation that you're going to be working with right here. So that's the toughest part of that question, is getting that equation. And now what you want to do is everything that we've learned in this section here. You want to pick out a number, or factors that you can multiply to eliminate the denominators. So let's say we multiplied everything here by n and 25 minus n and 4. So if you do that, multiply each term by each of these three, you'll get rid of all the denominators. So 1 over n times these three, well, the n's cancel out, and we're left with these two over here. So it's 1 times 25 minus n times 4. The second term, the 25 minus n and the 25 minus n will cancel out, and I'm left with 1 times n times 4, or just 4n. Multiplying these three factors times the 1/4, the 4's cancel out, and I'm left with 1 times n times 25 minus n. So this is sort of what you're looking at, and now you go ahead and you expand, multiply this out, and solve for n. And it's probably going to be a quadratic, so you might have to use that too. So I'll let you finish that question. I'll give you a few minutes, let you finish that question on your own for those who haven't started, and see if you can get the rest of that. Okay, so for those of you interested in looking at question number 8 there, real quick, this is how you would finish that. You would get two values for n, 20 and 5. Now please notice that these are not the two numbers themselves. These are just two options for the first number. N could be 20 or n could be 5. Now it just so happens that if 20 is n, then the other number is 5. And if one number is 5, then the other number is 20. So both of these are solutions, and they, one leads to the other. That's a coincidence. Your solutions are not always the solutions for n, right? These solutions are just n. You still have to do 25 minus n to get the other one. So the numbers are 20 and 5, and if you do a quick check there, plug in those numbers in, it works out. Okay, so that's the answer for 8. I will show you also the answer for question number 5 here. I think I've done a separate video on this question, but here's the question for number 5, talking about perimeter and things like that. So